And I'm live. Hello, today is 1st of August 2025, Friday, and I haven't streamed for a couple of days because I couldn't. I was not at home, but now I am back. And yesterday was also a Codeforces competition 1031040 contest number. And in today's stream, I am going to see what I did. But I have mixed feelings about my performance in yesterday's contest, and let me show you what I did. Yep, I am live, YouTube says, and yeah, I was watching Thomas Shelby. So what did I do? And yep, this is my new terminal setup. See, Mac OS allows you to create multiple desktops, and since Ghosty does not have a background feature, I have made my ghosty become transparent. So this at the background is my wallpaper. I have removed all the icons from my desktop, and the menu bar hides itself when I'm not there, and also the dock hides itself when I'm not there. And this separate desktop is completely just for my terminal. And yeah, this is it. This looks cool, very cool. And as for Codeforces, my rating did increase in yesterday's contest. It is now currently highest as it has been till this point. Yesterday I gained 86 rating points, but I am also happy, but not very happy with my performance. I mean, the second last contest that I gave, I only did one question and my rank was 11,000, which is very horrible. I lost rating points. But yesterday I did 4 questions. My rank was around 3,000, this much, and I gained 86 rating points. My rating did increase, but the thing is, the time it took me to do all these questions. See, this many wrong submissions. I gave 3 wrong submissions for problem number 1, which is supposed to be the easiest. I gave 3 wrong submissions for that. And then I gave 1 wrong submission for problem number B, and then I was able to do it. And yeah, this was pretty bad. Let me show you this in another format. Yep, in this. So as you can see, I did the second question first, and then I did the first question because I gave a lot of wrong submissions for this one. Then I left it, and then I started working on question number 2. Then I did that, and then I also did question number 1. So this is the part with which I am dissatisfied in my yesterday's performance, but this part was amazing. I did question number 3, which I thought I might not be able to do, but doing that was good. Okay, doing that was good, and if this were the whole thing that I did yesterday, only 3 questions, then my rank would have been about 4 to 5,000, and yeah, it would be a normal competition contest. But then it took me 1 hour, over 1 hour, but I did question number 4, and that was fucking amazing. And my rank is about 3,000 now because of that last question. And yeah, it takes a lot of stamina to think for like 2 hours and 18 minutes. So stamina is the thing. And now I will show you my solution, what I did. And here, final standings. And due to some reason, this thing here says 2 out of 9. 2 out of 9. Wait, okay, that is division number 1. Okay, okay. So that is fine. This is the contest that I gave. Problems. Problem number 1. And yep, since while solving a question, I like to do this thing. Uh, like to have my terminal to the side. Yeah. And if I have my terminal full screen, I lose the background. So that is something I have to deal with. Multiset, question number 1, the easiest in yesterday's contest. Let's begin with that. Here, for a multiset T consisting of non-negative integers, we define sum T is the sum of all the elements in T. For example, T equals this. T is a multiset, and a multiset is a set in which you can have a single item multiple number of times. Simply that, multiset. And there are two functions, sum T and max T. Sum T takes in a subset of T and returns the sum of all the elements in that subset, and max T returns the smallest positive number that is not in the subset. That is, if you choose this subset 1, 0, 1, 1 and 3, then the smallest positive integer that is not in the multiset is 2. You have 0, then you have 1, but you do not have 2 here. So 2 is the smallest positive integer that is not in the multiset. So you have two functions, sum and max. And then yeah, you are given a multiset S, and I have two options, two operations that I can do. I can choose a multiset. I can choose a subset of the given multiset and remove that from the given set, and then whatever was returned by sum T, add it to my score, and initially my score is equal to 0. This is one operation, and the other operation I could do is take max T of a subset of the given elements, and whatever is returned by max T, add it to my whatever is returned, add it to my score, and then remove the subset from the given T, from the given subset, from the given set, and which means that, and at the end I have to output the maximum number, the maximum score that I could have. And for this I thought a while. It took me 47 minutes to do this, and this was so easy. So performing this operation when you are taking the sum, just taking sum of all the elements is the best thing you can do. And the only reason that you would do this operation is when the number that is returned by max is greater than the sum of the subset that you have passed into max. And that would only be true when you are choosing 0 as the only element in the subset, which means that in this thing I could use this 0 as a single subset and pass it to this max function, which would return me 1. So I lost a 0, but I gained a 1, which is positive, which is like good thing, positive increasing in the sum. So my sum became 1 after that, and then I can just simply choose the remaining subset after removing the 0. So the answer would be 1 plus 1, 2, and 1 extra 1, which I got for the 0. So answer is 3. And in this case, I do not have any 0, so I cannot have any extra ones. And therefore, the answer is the sum of this subset. And what did I do? Tmux. Wait, I think I don't have tmux running. Yeah, let me increase the size also. Tmux set, which is a command which I have written, which sets all my servers, and go to contest cd 1040, and question number 1, what did I do? I am first taking n, the integer, and then I create a array or a vector of integers, and I am initializing s equals 0. S is going to summarize the whole array. You take the sum of the array, and then z is the number of zeros that I encounter. Then I take in input c in x into x. I add it to s, and if it is a 0, that is, if not x, that is, if x is a 0, then increase the number of zeros, and the maximum output I could get is the number of zeros plus the sum of the whole array. And that is simple. And still it took me more than 40 minutes to get this right. After doing that, I went to this. I did this one before and then I did the first one. So anyways, there is an array a1 to an consisting of values 0, 1, 2 and an integer s. Okay, so in this one I did more fine tuning, and I think my solution is not very general. Let's see what I did. Yeah, look at this. Let me open this in a different screen. So I wrote quite a bit for this one, and okay, so here the thing is, you are given an array an, and you are given an array an, and there is one person, Alice, and she wants to get to this. She starts from this element and she has to at the end go from this to this, and whenever whichever element she lands on, she adds that to her score, and at the end her goal is to get this target. And what she can do is she can make any movement. She can, whenever she is at an element, she can go to the right or to the left, and whenever she lands on an element, she adds that number to her score. And even if she goes to a number multiple number of times, that number will be added to her score multiple number of times. So, and we are against her. We do not want her to get to that score, and therefore we have to rearrange the given array in such a way that it would be impossible for her to reach this score of 6. And for this, what do we know? At least she has to go from this. Let me open Excalibur. Let's say this is the given array, and no matter how I arrange this array, she has to go from the left to the rightmost element, and therefore she will add all of these numbers at least once to her sum. And so let's say t is the target sum that she wants to achieve, and the total sum is, let's say, s. And if we have s greater than t, and s is the minimum sum that she can get, and the minimum sum that she can get is greater than her target sum, then we can arrange the array however we like. She will never be able to reach the target. By the time she reaches end, she will be too far ahead of the target. And if it is equal, right, so this thing, and if s equals to target, then no matter how we arrange this, we can never arrange. She will get the sum. She will traverse through all the elements at least once, and she will always get to the target. So in this case, there is no way that we can arrange this given array so that she does not reach the target. So we will output -1 in this case. And now when s is lower than the target, this is the case that we have to look for. And in this, you have to see that we have the only elements that there are in the array are 0, 1, and 2. And if we put a 0 and a 1 together, let's say, then, and here the sum is, initially the sum is equal to 3, right? If you go from right to left, you get the sum 3. 0 plus 1 plus 2 equals 3. And let's say the target equals 6 or any number. And if you have a 0 beside a 1, then she can go from 0 to 1. And let's keep a current sum. Currently, the sum becomes equal to 1. Okay. And then she can go back to 0 and then back again to 1. And thus her sum increases by 1. It becomes equal to 2. And then she does this again a couple of times, and her sum becomes equal to 4. And then from here she can go to the last element and her sum becomes equal to 6, which is equal to the target. And so she can always reach the target in this case, which means if she has a 0 and a 1 beside each other, she can increase her sum by 1 every time. She would have this ability, and no matter how great the target is from the sum, she would always be able to reach the target. So we do not want to put 0 and 1 together, which means we would have to put 2 in the middle. That is something like 2, 0, and 1. If we are taking only 1, 1, and 1, 2, and 1, 0. And what kinds of sums does this does this allows her to have? In this case, if we have something like this, then she can increase her sum by going to 2, then coming back, and then going back to 2, which means if she was at 2, she went back to 0 and then went back to 2 again, which increased her sum by a 2 amount. So this arrangement gives her the ability to increase her sum by 2 into some number x. And another thing is that we have 2 and 1 beside each other. So this allows her to go to 1 and then back to 2, increasing her sum by an amount of 3. So this allows her to increase her sum by an amount of 3x also. So we have to see that target minus sum, if this thing can be achieved by some repetition of by some addition of 2's and 3's, then she would be able to reach the end always. And in that case we would output -1. But if not, then we can arrange them in such manner. Put all the zeros first, then all the 2's, and then all the 1's. And how do you check it? You check this by taking the difference. Let's call t minus s equals to the difference. And if this thing is, let's say, greater than 3, then you have to check. Well, first of all, this difference cannot be even. If this is even, then it will be covered by this 2x factor. And if it is not even, if it is odd, then see if by subtracting 3 from the number you get an even number, which you will, then also it is messed up. So that is what I check in my solution. First, I take in n and s. N is the number of elements in the array. S is her target, and yes, I am representing that by s. And then I create an array A of size n, and then I create sm, which is going to be my sum, my running sum of the array, the smallest score that she can have, and then ones and twos, number of ones and twos initially equal to 0. Then I take an x, the current element, add it to my sum. If it is a 1, increase 1. If it is a 2, increase 2. And if sum is greater than the target, then I can just arrange them any way I want, and in which case I am just outputting them in the original manner that I got them. And if sum equals target, then there is no way I can arrange them to stop her from reaching the target. Else, I have to see a few things. S minus Sm, that is the difference, this thing. If this thing is even, and if this thing is even, wait, no. If this thing is not even, why this would only be true if this thing is not even. So this thing has to be not even, and also not a factor of 3, and also if it is greater than 3, then I subtract 3 and see is it even now. And if it is greater than 3, I see is it even when I subtract 3 from it, and if it is not greater than 3, then I just output true. And if that is the case, then I output ones, the amount of times that I saw ones in the input, and then I output twos for the amount of times that there were twos in the input, and then I output the remaining number of zeros, which should be n minus ones minus twos, and then a new line. And else, if that is not the case, then I output minus 1. And I did that question right here. Got the wrong answer in the first test case, which was like very stupid. I didn't see what was happening, so that was bad. And now moving on to question number 3. Nope, that is question number B. Question number C. And this one was cool. This one was actually cool. Right? Yep. This one was cool. So in this, I am given a list of pairs. Let me drink water. In this, I have been given a list of pairs, and the way that I visualize them is like this. Okay, these are the pairs that I have been given, and then I create a line, and I have wait is 0 here, then 1. This is the number line, as you can see, 3, 4, and let's say till 5. And these pairs represent segments of this line segment of the number line. So 1, 2, and we also have 2, 3. We have 1, 3, and then 3, 5. And we have two functions, fx and gs. Yeah, we have two functions, fs and gs. Fs and gs. What this s is, this s is a subset of these points. This function fs takes a subset of these points and returns the area that is covered by these subsets. For example, if I were to given this and this as a subset to this f function, that would include this interval and 1 to 3, this interval. So the area covered by these two elements would be from 1 to 3. That is, I guess it is inclusive. And if it is inclusive, then is it inclusive? If it is inclusive, then the area would be 3. And if it is not inclusive, then the area would be uh, 3 minus 1, 2. So let's say it is inclusive, and then the value returned by the fs function would be 3. So that is what the fs function does, and gs function takes in a subset. Let's say it takes in the subset this 1 2 2 3 and 1 3, and then it sees it is treating these numbers as nodes, and these pairs are telling that there is a connection. GS function is treating these numbers as nodes. So here we have node 1, 2 and 3, and these tell the GS function that there is a unidirectional edge between 1 and 2. So these two are connected. Between 2 and 3, these two are connected, and between 1 and 3, these two are connected. And GS function takes such a subset and returns the amount of cycles, the amount of elements which are the amount of nodes which are a part of a cyclic graph. So in this we have one cycle which has 3 nodes as a member of it. So GS function GS, when taking in this input, would return 3. And in this question our goal is to minimize fs minus gs, and yes, this is g, fs minus gs. So this was pretty cool. In this question, let's say do not visualize the nodes like this, visualize them on the number line, and if you do that you will see some crazy stuff. 4 5, okay. And let me copy the question again. You have this thing here, and right, and then for a cycle to form like this, you would need some interval, and then at least 2 sub intervals like this. You need a bigger interval, and then 2 sub intervals which have their ending and starting point at a single element. So this thing forms a cycle, and this is the only way that you could reach a cycle, and this cycle contains 3 elements. You could achieve a cycle which has more than this. Mm, you could have a cycle which has more elements, which would involve something like this. In a cycle like this, you have one big pair right here, one big pair in this one, then one edge here, one here, one here, and one here. That is 5 edges. So that is that, and you want to avoid these cycles and also get as much area as you can, and you can easily do that if you just take in your subset this bigger interval and do not take any of these. So you will never form a cycle. And for that, you need to arrange your pairs in such a way that would make this information very accessible. And for that, the way I did it is I first sorted all of these pairs based on their starting value. And then if two pairs, like here, if two pairs have this and this, the first element equal, then arrange them so that their second element is greater. That is, arrange them in ascending order with their first element, and if their first element is same, then arrange them in descending order depending on their second element. what this would give me is in something like this range, I will have the first pair would be the first, the leftmost thing I could have, and I add that, and I am guaranteed to have that. I'm guaranteed to have the longest range first because after that I'm sorting this thing depending on, I'm sorting this thing in descending order depending on the second element, the the range. Therefore, if I were to sort this thing, this input, I would first have 1, 3, then 1, 2, then 2, 3, and then 3, 5. Therefore, I got the first range, and till I see a number that is different from the starting value that I have already considered, I will not do anything with this. And also, if the first number is different, I have to check the second number. The second number has to be greater than the last second number. So I will not do anything with this even, and I will go here, and here I see this is greater than the first number, and its second number is also greater than the second number of the last one. So I take these two elements, which are 1, 3 and 3, 5, which if I pass this subset to Fs, I would get 3 for this 5. In total, I would get 6 because 1 and 5 are also inclusive. And if I pass this to GS, since there are no cycles, I would get 0, and the sum and the difference would be maximize. 0 minus 6 minus 0 would be 6. That is cool. And in Vim, that is what I did. But implementing this is different thing, and I don't know how I was able to do this in such an elegant way. You see what I did there? I used this thing, iota, this iota function, to sort these using a reference function. The first time that I saw sorting an array like this was in a solution which was submitted by Tourist. So in a way, Tourist was the man who taught me these things, and that is cool. Hello. The bandwidth in this bottle is low. So in here, I take an n, the number of pairs, and then I create a vector of pairs of integers. Then I take in all the pairs, and then I create a vector of size n, and then I fill that vector up from the starting till the end, starting with the element with the number 1. And what this function does is it takes a iterator from the start and the end for some iterator, for some iterable value like a vector or a set or something like that. And this is the starting value, and so at the start of the array, it puts this function iota puts 0, and then at the next point it puts 1, and then 2, then 3, then 4, then till n minus 1, so on. And then I'm sorting this thing, and to sort I will be getting, and these numbers starting from 0 till n minus 1 represent the indexes of the pairs that I have taken in. And then I want to sort these indexes, which are a metaphor for sorting the actual vector of pairs, which means that, and what does, how is this beneficial? This is beneficial because I am not sorting a vector of pairs, and instead I'm sorting a vector of integers, and sorting a vector of integers is much less expensive than sorting a vector of pairs. and therefore I sort it. And how am I sorting it? I'm giving it a reference function. And what is a reference function? A reference function, you a reference lambda function, and I think reference is the right word here. This is a lambda function, that is, this function does not have a name and only exists at the place where I defined it. And this and inside it says that this is a reference function, which means that this function is defined in this scope, in this main function scope, and everything that is a part of the environment where this function has been defined will be available at the place where this function will be called by this sort function. Therefore, inside this, I can have access to A. What is A? Because A is also in this scope right here. A, I do not want to use my mouse anyway. A is here a vector, and since this is a reference function and this function will be passed in with all of its reference, therefore I also have access to the A vector inside this function, and thus I am sorting the index. I take the index of one element and compare the first element, the first part of both the pairs, and if they are not equal, then I sort them in ascending order, and if they are equal, then I sort them in descending order according to their second element, and that is cool. After that, I initialize a vector answer which would contain all the indexes of the pairs which will be a part of my subset, and it would always have the not the first pair which was passed on to me, but the first pair which the pair which comes first after sorting all the pairs. So this has SS. SS is contains the indexes in a sorted order. So SS 0, that is the first index which appears after sorting the pairs, and then LL is last left and LR is last right. And then I start iterating through all the pairs, and I am iterating them after sorting them and not in the manner which they were provided to me. And then I'm checking if the first number of the current pair, if it is not equal to the last left value and the right value of the current pair is greater than the right value of the last pair which I added, only then add the index of this pair, which is SSI. SSI is storing the index of the current pair, push back PB it to the answer, and update the last left and last right values, first and second, and then answer the answer. First of all, I have to answer the size of the answer, and then I have to answer all the elements in the answer, and that is how you have to answer this thing. And I got it right in first try, which I was unable to do with question number 1, which is crazy. Hello. And now question number D, and I got this right, and I'm actually very proud for getting this right, even though I did an overkill in this question number D. If you see, I wrote quite a lot of code to get this right, but yeah, I got it right. The part that I wrote starts from here and it goes down and down and down, and shit, I wrote more than 100 lines of code for this question, but it was cool. It took me more than an hour to get this right. First, I got a trivial solution. It exceeded on time. Then I optimized it a bit and it succeeded test number 6, but failed on number 7. And then I optimized it further, which was I suppose, which was very clever. I will show you how. And then it got accepted, and I was happy, I guess. So in this, you are given a permutation from A1 to AN, and yeah, I have to create a new array from the given permutation, and either I add the exact element from the permutation to my new array, or I add this thing 2n minus the element in the permutation. So if given a permutation like this, and I am supposing that you guys know what a permutation is, and I guess, yeah, if you are doing Codeforces, you know that. So if you are given this thing, mhm, if you are given this thing, and wait, this is too small. Yep. If you are given this thing, then you want to create a different array from this given array. And in this new array, let's say this is original and this is new. And in this new array, either you have the same element as you had in your original array, or what you can do is, here the length of the array is 6, 6, and 2 into 6 would be 12, and you subtract some element. So in this, at this current position in the original array, I have 2. So here I could either add 2, keep 2 as it is, or I subtract 2 from 12, and whatever I get, I put it here. That is 10. 12 minus 2 is 10. And here I could either add 3, or 12 minus 3, that would be 9. Or here I could add 4, or 12 minus 4 is. So at every position, I have two choices. At every number, either I take the number as it originally was, or do 2n minus that current number and put it there. So, and my solution, I got it right. Like, I don't know how I got it right, how I got to the algorithm, but it worked. So what do you have to do? Shit, yes. What do you actually have to do? In this permutation, there are a number of inversions, and you need to reduce the inversions by performing these operations. And what is an inversion? Here, if you were to count the number of inversions in this, it would be, see, inversion, if you have two elements, one element on the left, any element on the left, and some element to the right, and this right element is to the right of the left element, and if you have left element greater than the right element, that is an inversion. So if you were to count the number of inversions in this array, you would start from 2 and go to the right and see 2 and 3. Is 2 greater than 3? No. So number of inversions is 0. Then you go to 4. Is 2 greater than 4? No. Then you move on. You go to 1. Is 2 greater than 1? Yes. So number of inversions increases by 1. And 2 is not greater than 5 or 6. So number of inversions remains same. Then you start from 3. You go to 4. Is 3 greater than 4? No. Number of inversions remains same. Then you go to 1. Is 3 greater than 1? Yes, it is. So number of inversions becomes plus 1. 1 plus 1 equals 2. Then you move on 5 and 6, and 3 is smaller than 5 and 6. So inversions remain 2. Then you move on to the next element, that is 4. You start iterating from 4. Is 4 greater than 1? Yes, it is. Therefore, inversions become 2 plus 1, that is 3. Then you move on to 5 and to 6, and both are greater than 4. So inversions is still 3. Then you move on to 1 and you go to 5, you go to 6 and no inversions, and then you start from 5 and you see 6. 5 is smaller than 6, so that is also cool. So in this array, at the start you had 3 inversions, and then you have to make this new array in such a way to minimize these inversions. And yep, either you add the element as it is or do 2n minus the element and then add it to your new array. So my formula, what it does is, let's see, 2, 3, 4, 5, 6. My formula my algorithm calculates the number of inversions, initial number of inversions. Initially, as we calculated here, the number of inversions is 3, and then I start iterating from starting to the end, and I ask a question. If I change this number to 2n minus the current number, let's call the current number x, 2n minus x, which would be, n is here 16, 6, so 12 minus 2, 10. If I make this equal to 10, what happens to the number of inversions? Does the number of inversions decrease? And in this case, the number of inversions actually increases, because earlier we had 2 less than 3, 2 was also less than 4, and it was also less than 5, it was also less than 6. I forgot to write 1. Yeah, 1 comes out of 4. And so 2 was not forming any inversions with any of these elements, and it was only forming one inversion with 1. But now it is forming an inversions with these elements with whom it was not forming an inversion earlier. So the number of inversions increase, therefore I will not convert 2 to 10. Yep. Therefore I will not convert 2 to 10. So my number of inversions remains same. Then I go to 3 and I ask the same question. Do I keep 3 as it is, or do I make it equal to 9? That is 12 minus 3 equals 9. Do I make it equal to 9? And then I calculate the number of inversions. And this also increases the inversion count. So nope. And I ask the same question with 8. With 4, do I keep it as 4, or do I convert it to 8? Which is also bad. So no. And then I ask the same question with 1. Do I keep 1 as it is, or I can convert it into 11? And I think, let me see, with 11, initially and yes, the method that I'm using to calculate the number of inversions by only switching one element is also crazy. Let's say I convert this one into 11, and initially I knew that when this was 1, my number of inversions was 3. So now I have to see. I start iterating for all the elements that are to the left of the number that has been changed. I check one thing, that was this number greater than 1? If it was, and now it is smaller than the new value of 1, then my number of inversions decreases, because earlier 2 was greater than 1. Therefore, it caused one inversion. But now 2 is lower than 11. So no inversion because of that. So cut it off. So at 2, my inversion has decreased by 1. Then I go to 3 and I ask the same question. Was 3 greater than 1? Yes, it was. And now is it lower than the current value of 1? Yes, which is 11. Yes, it is. So decrease it by 1 again. And I asked the same question with 4. Was 1 greater than 4? Yes. And is it lower than 11? Yes. So decrease this by 1. So that is what I do with the elements on the left. And with the elements on the right, I have to see, was this number greater than the original value, and if it was, is it now lower than the current value? And unfortunately, we have 5 was greater than 1, and now it is lower than 11, which has increased the inversion, because earlier we had 1 5, and 1 5 is no inversion, but now we have 11 5. 11 is greater than 5, and this is causing an inversion. So number of inversions has increased by 1 because of this, and the same with 6, it has also increased an inversion. So in total we lost 3 inversions but only created 2 inversions. So at the end, if I change 1 to 11, the inversions would change from 3 to 2, which is cool. The number of inversions has decreased. So wait, copy, paste. So what I can do here is change this one to 11, and currently inversions is 2. And then I move on to 5 and I ask the same question. Do I keep this 5 as it is, or do I change it to 12 minus 5, which is 7? And if I do that, then I have to ask a question. Does the number of how does that affect the number of inversions? It only increases one inversion, an inversion of 7 and 6. So we do not want to do that. And I ask the same question with 6. Do I keep 6 as it is, or do 12 minus 6, which is simply 6? So it does not matter if I do changes it or not. So the minimum amount of inversions we could have after doing all of this is 2, and that should be the answer. It is 2. That is cool. And yes, I am speaking a lot. Okay, so that is just my algorithm. And the crazy thing in this was there are 2 methods that I'm using to calculate the inversion. First of all, the initial method, which I represented here, which I used here to calculate the initial number of inversions. And then there is the second method, which I am using to calculate the inversions when I have changed only one number. And so yeah, I did some optimization. Earlier this algorithm takes n square time to calculate the number of inversions, because n square. Then I did some optimizations. I implemented merge sort, and that changed my algorithm for calculating inversions from n square to n log n. But still it was not fast enough, because I was doing this thing for every element, which made the overall algorithm into n square log n. And that was my second time limit exceed error, this thing. And then I figured out this approach of calculating inversions, which made I had to use so since I had implemented this merge sort version of finding inversions, so I had to do this once and log n to find the initial amount of inversions, and then for every element I had to calculate the new inversion. So for n, and calculating the new inversion would only take n amount of time, so n into n So the final algorithm took n square time from the initial n square log n to n. And my the very first algorithm that I implemented took n square time. Then I optimized it a bit. It became n square log n time. Then I optimized it again and it became n square. So that is cool. And here is the implementation. And yeah, find inversion. This thing does a few things. Like there is this global variable called inversion. These whole 23 lines, no, 23 from the start. How many lines have I selected? How do I see that? 39. These 39 lines are like way overkill. I could have implemented the first n square algorithm to find the initial amount of inversions, but I didn't know. So shit, I really do not want to get into how this thing works. It just, whenever I'm trying to find the number of inversions, initially I take them equal to 0, and like a typical merge sort works. It's like a typical merge sort. You have an array, you divide that array, you have an array, then you divide it into half, and then you get 2, 3, 4 here, and uh, 11, 5. What the fuck? No, this is supposed to be 1, not 11. Yes, that, and then you divide it again into 2, 3, and 4. Well, in implementation level, you divide it not in this manner, 2, 3, and then 4. You divided it like this, 2 and then 3, 4, but whatever, that does not matter actually. 1, 5, and then this becomes 6. Then you further divide this 2 and 3 into 2 and 3, and this is 4. This you divide into 1 and into 5. And after dividing, and when you have only arrays of size 1, you do the merging. And what happens, we do not care about sorting the thing, we only care about the number of inversions. Initially we are taking them equal to 0, and then while merging, I take the first left element and the right element, and I see which one is smaller. I put that here, and then the other one. So this becomes 2 and 3. And I increase my number of inversions when I see that I'm adding a right element, but there are elements left on the left side. And it would be better visible if I flip these from this to 3, 2, or in the different color. This becomes 3, 2, subdivide these, this becomes 3, this becomes 2. And when I am merging these, I see that I am adding 2 first, and then I am adding 3. And when I added 2, there was one element on the left side, which means I had an element a smaller element after a bunch of bigger elements, which means I had an inversion, and I have to increase my inversion counter by how much amount? That would be equal to the remaining size of the number of elements on the right, and which here is just 1. So I increase my inversion by 1. It was originally 0, now I have added 1. So this thing is sorted, and now I merge this and this, and this becomes 1 and 5, which is not bad because this they were not causing any inversion. And then I add 4, 2 and 3, merge these, this becomes 2, 3 and 4. They were also not creating any inversion, so we are cool again. And I merge this array and this gives me 1, 5 and 6, so they were also in order, no inversion. But now we have something crazy. Now I see I have 1 here, and that means I will be adding 1, but 1 is from the right, and I have a bunch of elements from the left, all uh, which remain in the left. So which means I have an element to the right which is smaller than a bunch of elements which were to its left, which means I have to increase my inversion, and the amount by which I have to increase the inversion is this, is the length of this left array, which is currently 3. So I add 3 to this thing, then I see, so remove 1, then I compare 2 and 5, I add 2, then I compare, and adding 2 is cool because it is from the left and it was already left, so no merge conflict. Then 3 and 4 both are smaller than 5, then 5 and 6, and that does not cause any merge, so I have my array sorted, and the number of inversions I had is 4. And now you might say that when I calculated it before, it came out to be 3. Why is it 4 now? It is 4 now because here I changed the order of these two elements. In this step, I changed the order, which increased the inversions by 1. So 3 plus 1, 4. And that is what is happening from this to this. This find inversion thing updates this global variable inver to the value, to the number of inversions in the vector that was passed into it, and that is cool. So initially I take in n, the number of elements, then I take in the permutation, and then I find the initial amount of inversions, that I put that inversion and put that inversion count equal to the minimum possible inversion, and then I make O equal to 0. And what is O? O is keeping track of the original number that is in here. At one point I changed 1 to 11, so I need to keep track of what the original number was and what the new number is. So O is keeping track of this original number. Then I have C inver and P inver. C inver represents the current inversion and P inver represents the inversion before. And at some point I am comparing the current inversion with the minimum inversion. And yeah, and then I go through all the elements. I find the inversion right now, and I find the inversion, the amount of inversions if I get after flipping this number, and if the new amount of inversion, that is current inversion, is lower than the minimum inversion, then I make that minimum equal to the current inversion, and previous inversion becomes equal to the current inversion. Else I keep that element, I put that element, make that element back equal to its original value, which is in O, and current inversion, which is the updated value of inversion, becomes equal to whatever the previous amount of inversions was. And I think previous amount of inversions would always be equal to minimum, so I don't even need this. I can make it equal to min, and B equals C. I don't need this. Yep, that is the only time I'm using P inverse, I guess, and it will still work. And yes, it does. Error due to some reason. Yeah, correct. So it is still working. That is cool. And I'll drink a bit of water now. Hello. And I had two methods for calculating inversions, and I would like to test how their speeds are different. So, and I guess I was working, yeah, find inversions. I was writing this function here. Yeah, inversion, and this thing. Find inversions, merge. So this function finds the number of inversions in n log n time. And let's create another function, find inversions, and let's make it take in a reference array, and it will return, it will find the number of inversions in n square time. So int inver equals 0, or int I equals 0, I less than a dot size I plus plus, and for int j equals not 0 plus I plus 1, and j less than a dot size j plus plus, and if a I is greater than a j, then inverse plus plus, and at the end return inverse. Now, even though the code for this n square algorithm is smaller than this n log n algorithm, it is much slower. So I would do this, and I guess I will, let me create a bigger array. And this is testing. This is like testing stuff. I'm playing right now with my algorithms. Reduce this, and so how do I calculate time? How to see time in C++? Hello, which software are you using? I am using Vim. Are you coding in terminal? Yes, I am coding in terminal. Terminal is cool. And I'm using Ghosty terminal. See time, use time, current time equals null, and enter time. And I guess current time in start time minus end time would be equal to time. Yeah, okay. So for int I equals 0, I less than 100. Yeah, I guess even 100 would not be that much. I have to increase the amount of numbers that I have on this thing. Okay, how do I do that? I create another array. Okay, vi, let's say b of size. I don't know. I don't have to give it a size. and repeat it. Repeat this thing 100,000 times, and 100,000 would be cool. And then for a auto x, auto reference x in a b dot push back x. And yeah, so b is very big at this point. And let's see, finding inversion once, how much time that would take. So what was it? C time, I guess. Time C, something like that. How to, or wait, I could do auto start time equals time null. Okay, null is not a good thing. What does this want? And let me see how to calculate duration in C++. Hi, hello. CHRONO. Okay. High resolution clock now start, and at the end also high resolution steady chrono. Chrono is like chronological order. It is, chrono means time in Spanish. Chrono high resolution clock now, and then duration would be end minus start. And how do I print the duration? Time elapsed is seconds dot count. And what is second? Second is duration. What is duration? Duration is this thing. And what am I doing with that thing? STD chrono duration cast chrono milliseconds duration dot count. Okay, I do duration dot count and typecast that. I am then typecasting that into STD chrono milliseconds, which is a part of duration cast inside the chrono name. No, chrono is not a namespace. Chrono, I guess chrono is a namespace inside the standard namespace. That gives me milliseconds. Okay, let's do that. I will try to remember what I read right now. Auto, not auto. Should I forgot already? Uh, auto start equals, don't have to use ST. Chrono, high resolution time, high resolution clock. Now, then I do this thing, find inversions using merge sort, and then auto end equals chrono, high resolution clock. Now, and then auto duration equals end minus start, and then end milliseconds would be equal to chrono duration cast. Yeah, duration cast into chrono milliseconds. Chrono milli, right? Yeah, chrono milliseconds. Chrono milliseconds. What thing? Duration dot count and ms chrono duration cast. What duration cast? What this thing? Do I need something like this? No. What is the error? I have to put duration into a bracket due to some reason. Okay, duration is not a function of dot count is not a function of duration. It is a function of milliseconds. Typecast. Okay. Now we are good. And then C out and log n took ms milliseconds. And then I would like to do the same thing with the other start, and instead of this one and here, and this is not n log n, this is n square. N took this many milliseconds. Lang plus plus find inversions not slash out. Okay, both took 0 milliseconds, which is amazing. Maybe how ms. Okay, I did something wrong. Maybe they are actually taking 0 milliseconds. So increase the size of the array. Now they are not taking milliseconds, not taking. They are taking milliseconds. Something is wrong. Uh, Duration is start and high resolution clock now. Then I start my function. Then I end my function and then do this. And duration is end minus start, which is how it is supposed to be. Duration end minus start. High resolution clock now. Start high resolution clock now. Duration in milliseconds is chrono. Duration cast chrono milliseconds. Duration dot count. Okay, let me do. Okay, yeah. Maybe I became too smart and did the make ms into integers. Maybe it is not an integer. Duration and minus start. And it's 2 seconds. Maybe it is taking too many milliseconds and do not have a higher resolution. I don't know. Let's do this. Standard chrono duration double seconds. Duration equals, okay, it will be typecasted automatically. So chrono duration second seconds equals duration, something is wrong, duration double. Okay, and replace all the ms with seconds. Seconds dot count, not seconds. Seconds dot count. I want not shit. Seconds cannot be equal to this. Yes, of course. Seconds dot count. And now I hope that it works, or maybe it won't. Okay, it is taking time. That is cool. And login took. Okay, I do not want to represent it in this manner. E power something. I can do this, I guess. Here. And there is a decimal. It should work. It should work. Despite that, let's see. And I do say milliseconds, even though. Okay. 6. See, I this double. Let's see if it works now with the double. And but shit. Okay. Double, how to represent double in C++, how to print double in C++ without exponential. Okay, this is the value, large value, fixed full precision, standard fix. Where is my value? Large value and small value. Okay, large value. I give large value to this thing. Set precision standard numeric limits double max digits 10 and pass it on to fixed. Print with fixed point notation, full precision. Print with the fixed point notation and specific precision. Say I want full precision, so I have to pass my value to this thing. Standard set precision. Let me see that how this thing is working. See out. And yeah, time taken n square n into n. Time is this thing. And this thing takes in seconds dot count, and yeah, then underlines. Same thing here. Instead of n square, I have n log n, and everything else remains the same. See, okay, that is a very big number. That is a very big number actually. Okay. Okay. They will appear in a good manner. Yeah, now we can directly compare them. So this number is smaller, this is larger, and the first one is merge sort, and the second one is n square, and the second one is smaller. Mm, I don't know. And this is due to their representation, some mismatch in the representation, something like that. What compiler are you using? I am using Clang plus plus. Let me try that. It's new for me. Looks like terminal. Yep, yep. Just enter precision 10. Okay, instead of full precision, set precision 10 or something. Okay, set precision. Let's see. 10, I would see 10 digits. Oh, okay, okay, okay. 10 land plus slash out. Guess there are more than 10 digits. 10 from the left. Yeah, I don't know how it is being represented. But yeah, merge sort takes uh, lower time than n square. So that is cool. And that is what I wanted to see. And my rating did increase in yesterday's contest, but it could have increased more if I just did these two questions faster. Yeah, this is very horrible. Like this person did it in 9 minutes, this also in 9 minutes, but it took me 47 minutes and we are at the same level. I guess his rating is lower than mine. No, his rating is not lower. He did this one faster, and that is what gave him an edge. Even though he did all this one we did at exactly the same time, but this one he took 4 minutes more than me, and here he took much more time than I did. And also I did a lot of wrong submissions for the first one, so that was also bad. So that is cool. That is for the contest part, and it has been 1 hour and 28 minutes. So I would do binary search questions, which I wanted to do. And for that, I have CP algorithms website. So this website is amazing. You have everything you need, even though I'm not following this right now, but you have algebra here, fundamentals, prime. I would like to go into prime number, how you find prime numbers. Finding primes is pretty cool. And I was on this numerical methods search, binary search. I have not done all the things above it. I'm just working here. I read all of this now. Then I guess I did this question. Yeah, I did this one. Or not. Unknown. Don't. Okay, my stream is still working. Shit. Yeah, that is crazy. So I'll just go to lead code and do a few binary search questions. Okay, I'm not signed in. Let me sign in. Okay, I am signed in now. Yep. Go here, binary search, sort it from easy to difficult. I have done a few easy questions and I would like to do a couple of more easy questions, then a few medium, and then maybe one or two hard questions. Yeah, just to get myself up with binary search. And I also watched, well, first of all, for binary search, I read this article and then I watched binary search video by Eric To. Binary search, this one. And there was also binary search in competitive programmers handbook. Here, binary search. And I have not implemented one way of binary search. In this, the author showed two methods for implementing binary search. No, he didn't show, yeah, he showed two methods. One is when you have a left value and a right value and you are subdividing it again and again, which is generally the method we use for binary search. But he also used this method in which you have a step, and every time you are taking a step, it is getting half and half. It gets divided into half. So let's see, count. I was unable to do this question. I don't know how to count the number of nodes in a graph, even though it is easy, but I don't know how to do that. And I don't even know how binary search would apply here. That is crazy. It does say binary search, but I don't know how. So I skipped that one. Let's go intersection of two arrays, maybe. Given to integer arrays. Let me drink a bit of water. Yep, given two integer arrays, num1 and num2, return an array of their intersection. Each element in the result must appear as many times as it shows in both the arrays, and you may return the result in any order. So 2 here appears 4. Wait, I did this question. I did this question. I am signed in. I did this question. Okay, it is part 2. In part, I did part 1. If I did this one, and in this one you had to, if when finding the interval, you only have to put that element once if it appears in both the arrays, but here you have to put that element as many number of times as it appears in the other array, which means we will be using a multiset. Some dates in vim. Shit, my z is not working. That is crazy. And 350. Yep, 350.cpp. And this is my boilerplate. Um, okay, so, and here I will copy this. The signature, and I have to return a vector. Okay, let's say, and I will be using multisets of integer of nums I will make multiset of both nums1 and nums2 by using a iterator. Okay, n1 nums1 dot begin and nums1 dot end, and okay, and then do the same thing with nums2, and then I will get the smallest element in nums1. Okay, so I will traverse that set and see how many times it is appearing on in the other array, and that should be for auto x in n1, and also I'm using a lot of memory in this one. Answer x1 if it is appearing, if n2 dot count x, then answer dot insert x and n2 dot remove, no, n2 dot erase, n2 dot erase x, erase that x one time, and at the end return vector of integer created using answer dot begin and answer dot end. And I think that should work. Let me, but first of all, check nums1 is this. Okay, let me check it first. And intersection, this takes in vector integer 1 2 2 2 1, and vector integer 2 2. No matching function call. Why would that be? Because I am providing an R value that is not what is wanted here. Now it is cool. Yep, now it is cool. And vector int answer equals this thing. And then see out answer. Let's see how that went. 350. 2 is not what I want. I want it multiple number of times. Okay. Okay. If there is an element here and if there, okay, then int c equals minimum of n2 dot count. I do not want to count it again. Int c2 equals n2 dot count x, and here if c2, then here minimum of c2 comma n1 dot count x. What is the type of this thing? Okay, C, and then add how to add an element to a multi-set in C++, a number of times without iterating. That is the thing. I could write a loop, but without writing a loop. Without a loop. Shit, yes, C++ documentation. C++ multiset. Not this. CPP reference. CPP reference multiset. CPP reference multiset. This thing. The font would be smaller. Yep. Key type, key value, key size, key compare, iterator, constructor, iterators, capacity by using these. Insert range. Inserts a range of elements. Okay, how do I use this thing? It only appears in C++23, which I am using. Count and find and stuff. I'll use a loop. For int I equals 0, I less than C, I plus plus, I plus plus, and answer dot insert x, and this thing. Okay, let's see. That is much more than I expected. And dot slash out 2 2. Okay, twice for both of them, and okay, so I would like to remove it afterwards. Okay, when I removed it, I guess I removed all the iterations, in which case I would do n2 dot erase just x, and it would fix all the problems in my life. Let's see. Yep, it does. The only concern that I'm having is I am using a lot of memory 3 times, and creating these multisets takes time, and then I'm iterating only once, so that is cool. This iteration takes n time, n is fine, and creating a multiset I guess also takes n time, so n plus n plus n plus n, 4n, 4 to 5n. Let's see how that goes. Hmm, cool. Okay, that is one of the best solutions, it seems. And which question are you doing? I'm doing this one. 350. Lead code 350. I'm practicing binary search right now. Let's see. This person has a better solution. I sort both of these arrays. Okay, that also came to my mind. Sort both the arrays, create an answer, 2 pointers in the first one and the second one. Then while both are smaller than the size, and if both of them are equal, then keep pushing them back as if whatever is the smaller one, increase it. Otherwise, if the other one is smaller, then increase it so that you make them equal. And that is also cool. So that is, but that didn't include binary search. This was not a binary search question. See this one, valid perfect squares. Given a position integer, positive integer, not position integer. Given a positive integer num, return true if num is perfect square or false otherwise. Now, that is cool. That will include binary search. That is cool. Question number 367. 367.cpp and print the boilerplate, then the function signature, and here inside this thing the number, and otherwise if no, then I return false. Okay, I return a boolean thing. Okay, int bool answer equals false initially, and for int I equals 1, I less than, I cannot use square root. Okay, shit, yes, I cannot use square root. Yes, okay. Okay, int L and R, and L equals 0 while R equals num, and while L equals R. Okay, what is the invariance that I'm using in this loop? I'm supposing that L, the square of L is always lower than the square of num, and that the square of num, the square of R is always greater than num. So R is never the answer. L might be or might not be the answer. And I am looking for the largest value of L that I can have. And K, yep, L and R. Okay, so L is always true, R is always false, and that is the invariance that I'm keeping. So int M equals L plus R minus L divided by 2. And if square of M, if M into M greater than num, if M into M greater than num, if the square of this is greater than R equals M, else if it is either equal. Okay, first I have to check for equal. Long sq equals M into M. So if sq equals num, then return true. Cool. If sq is greater than num, then R equals M, else L equals M. If it is lower, yeah, it would only be lower. And okay, will I be stuck in there? I could be stuck if L becomes 0 and R becomes 1. M will always be 0, and yeah, I could be stuck. So R minus L has to be always greater than 1 and return answer. Let's test this. Cout is perfect square 25. And 25, 16, 21. And what is the square of a big number? Square of a of 999 into 999 is this big number. So it's 998,001. How do I select that? Calculator is in the back. Swig and also some edge cases. 1 and 0. Blank, not this. 3, 6, 7, I guess. Yeah. Only true for the first two and not true for this thing, which it should have been, and it should also have been true for 1. 1 is also a perfect square of 1, and 0 is also a perfect square of 0. Okay, I can write them separately as edge cases 0 and 1. They will not fit here. If num equal to 0 or num equal 1, return true. That will fix the last two cases, but something is wrong with this one. This also has to be true. Right, I did the right thing. 998,001. 998,001, which is the square of 999. There might be some overflowing or something like that. Too long, 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 long. Mid would be a very big number. What is the range I could have? Num could be very big, so no. Num could be very big, so I should not start with that. I can do half, but half also does not help me. Log, I could do. Ah, I could find all the factors and see. Nah. Binary search is cool. Binary search is cool, but it is not working because the long long is very long. Yeah, and the number is very long. See, it does say 1 now because of long long, so that is good. But I guess it will break here in lead code. Let's see. Okay, well, here the value of num was small, but the maximum I can get is 2 power 31, which is very big. And if I do 2 power 31 square, that would give, that is cool. That is like exactly doable because long long takes 64 bytes, 64 bits to store its value. And yeah, that should like exactly at the edge. And that is the most optimal way. That is cool. Okay, how did this person do it? Is perfect square, low is 0 and high is the longest number possible. While low is lower than high, Okay, mid long square would be, yep, converted into a long. Okay, he has made mid into an integer, but now here after multiplying them, he is converting it into a long before assigning to a long. So that fixes the problem that I was facing. So what is the loop invariance that he is having? If square is greater than num, then high is mid. So it is high. Otherwise, if it is equal or lower than this. So, okay, you could do that if you are not exiting from the loop. And yeah, if you could do that if you are not exiting from the loop. But I'm not. I am exiting from the loop because I'm also checking if it is equal. And then I am exiting. Therefore, I cannot do this thing. And if I cannot do this thing, then I have to see that high minus low has to be always greater than 1, and that is what I'm checking for. High r minus l is always greater than 1, and then yeah, so that is cool. And yeah, here he also has to do this thing, which I do not like. This is cool. This is cool. How much time has it been? 1 hour 56 minutes. So 2 questions in binary search. I guess I'll do a couple of more questions which have lower acceptance rate. One more easy question, then I will move to hard. Low acceptance rate, easy question. This one, 41. Yep, 1346. Okay. Given an array air of integers, check if there exist two indices I and j such that they are not equal, and I is to the left of j and I is double of j. Okay, I can sort and then do n thing. Okay, no, I cannot actually sort because they have to remain in order, and the left one has to be greater than the right one. So what I could do is it would take n log n time. Yeah, n log n time. Yeah, that would be cool. 1346. 13446.cpp. Paste the boilerplate. And here, okay, int, no, not int, bool answer is false. Return answer, and for int I equals 0, I less than air dot size I plus plus for every element except the last one. I will do int L equals I plus 1 and R equals air dot, and then sort that thing. Nah, shit. No, this is not. No, this is not going to work because it is not sorted, right? Yeah, the array is not sorted. I have to return true or false. Okay. The obvious algorithm is n square, but no. N square other than N square. Length is not big. Length is the maximum length is 500. Maximum length is 500. N square log in now. Sort. Okay, what I could do is take in this array and create another iota array and sort that, and then see if such a pair even exists where one number is double of the other. If such a pair exists, then I will see do they satisfy this condition, and okay, this would only be equal, they have specified this thing because they might have 0 in the array, and 0 multiplied by 0 would be 0. So 0 multiplied by 2 is still 0. So that is for 0 to eliminate 0 from making it true. Okay, and yeah, so my idea is to sort this thing and see if such a pair which satisfies this first condition exists, and if it does, then I will see if do the index I and j appear in this way, and if they do, then we are cool. And thus the major time that we are spending is in sorting the array, which takes n log n time, and then we are iterating through this only once, so n plus n log n, which is just n log n, and which is better than n square. So let's see. Okay, this takes in a reference, so sort error dot begin and error dot end, and yeah, nope, that is wrong. I need vector int ii of size air dot size and iota ii dot begin and ii dot end, start with 0 and then sort ii dot begin ii dot end and a uh, a reference function like this, which takes in int I, int j, and return air I smaller than air j. Okay, yeah, that is good. And then I can iterate through air, and current element would be air I, and I have to look to the left for the double. So entity equals 2 into air I and a air I, and so in L equals I plus 1 and R equals air dot size, and I do not want to call size again and again, so int sz. Z is not fucking working due to some reason. My Z key is now working when I press it very hard. Sz equals air dot size and s Z. Z is not working. SZ. And then C, F, this, and Z. Now it worked perfectly. That is cool. C, F, this, Z. Now it is working fine. So left and right. What was I doing? I have left. I have right. SZ minus 1 actually. And what is the invariance? Invariance is that L might be the answer or lower than the answer, and R is always greater than the answer. Okay. Then while R minus L greater than 1, I will do in M equals L plus R minus L divided by 2. That is M, and if air, no, I is not the thing. I, yeah, I, and yeah, that sounds crazy, but that is correct. And if air, I, because mm, I want to index in the array as if it were sorted. If this thing equals T, the target, then we are cool. Then we are very cool. And what would I like to do? I would like to see if M, right. Now, if I greater, it has to be greater than IIM. If that is the case, then answer is true. And I can like actually break away from everything. And here also I will break out of this, will break out of this while loop, and if answer, then break, and I will return answer. Or I could return true. But if it's not, then break out of this while loop. Yeah. And also make sure that the current element, which is R I, it is, that is, it is not 0. That would be bad. Let's see, not 317, it is like 13 something, 1346. Yes, because I haven't given any input. So okay, add another, make this a right reference, and then see out, check if exists, and call this with this vector. What are the vectors here? 10 to 5, 10 to 5, 3. Let's see. This should output 1, or it would never end, or it might never end. Shit. Yes, because fuck yes, of course, I'm not changing L and R. So if the current value, which is air II, this is very error prone, so let me say int C equals a air I M, right? And C. And if C lower than target, then L equals M plus 1 equals M, else R equals M. And I feel like something is wrong in this. R and L are representing the index in II, and I'm using those indexes to, and I'm using the values stored in II as indexes in ARR, right? The value in II as an index in ARR array. Okay, this seems cool. 0 is not the correct answer. So the AC is too high, but I will fix that later. Why are you not doing IDE in, not using IDE in lead code? I do not like the IDE in lead code. And how many questions you have solved till now in lead code? I will have to look that. Hamiltonian path on dodecahedron. I do not know Hamiltonian path, and unfortunately, I don't even know dodecahedron. Dodecahedron, 2D figure with 20 sides. Dodeca. Deca is 10, and dodeca, I guess it is either 12 or 20. New M, let's go. Yo. And oh, Tmux as well. Yo. Yep. And dodecahedron. Okay, it is a 3D figure, not a 2D figure, with 12 faces. Well, at least I got that 12 part correct. Hamiltonian path. Shit, there is a lot that I have to learn. Hamiltonian path is crazy. And just so you know, there is a leetcode.nvim dashboard plugin. Okay, leetcode nvim. That is cool. Okay, I will look that up on my time. Nice. This is actually cool. Whenever I see terms like these, like Hamiltonian path or acyclic curve or stuff like that, which I do not understand, it is very inspiring. It feels very good to just listen to these things, watching Veritasium videos and Three Blue One Brown. And I was watching this thing, Lex Friedman. What was the name of the guy? Richard Karp. Yeah, and he was talking about some stuff which I do not understand, but yeah, it felt really cool. Config never ends. It just keeps on going. Yeah. And okay, onto this one. I got it wrong due to some reason. even though I shouldn't have. C out, I, C, I, C, 1320, which should be correct. Yeah, carp of the Robin. Yeah, yeah, same guy. Cool. How do I start CP? I'm a very beginner in coding. Yo, bye. Good. Oh, gotta go. ATB, all the best. And bye is bye. Okay. How do I start CP? Well, you can. The way that I started CP was I started by solving these problems on CP31 sheet. You can look it up. It is free at tleeliminators.com. And yeah, start solving from 800 level and yeah, just do that. That should help you quite a bit. And if you are beginner in coding itself, not to CP, then I would suggest this CS50. Yep, listen. You can go to edX.com and there you will see this course CS50. It is taught by Harvard and it is free and it is for beginners in computer science, introduction to computer science. And this is very amazing for beginners. It has video lectures and pretty hard assignments. If you are a beginner, for a beginner, they are pretty hard. And yeah, new course starts today. Go and grab it. Every lecture is free on YouTube. That is cool. And yep, I outputted. Okay, I want to open this to the right, so R, yeah, cool. CD stuff, yes, say, and not slash out. 10, the smallest is 3 is not the smallest number. Why is 3? 10. This is not correct. Something is wrong with this. II starts at 0. Okay, I'm sorting these indexes. Okay, okay, cool. Cool. 1 is at the start and okay. In the thing that is printed here, this thing, this is that the number at index 1 is the smallest, which it is. And after that is the number at index 3, which it is, which is actually like even 3. And then is the number at index 2, which is 5. And then the largest number is the number at index 0, which is 10. And that is true. So that much is correct. And then I am iterating starting from 0 to I. And okay, let's say I start with I equals 0, which I do, and I see that the smallest II1, which is II0, II0 will give me 1, and air1 is equal to 2, which is something. So and then I see multiplied by 2, 2 into 2 is 4. So I'm looking for 4, and left is equal to 1 and right is equal to the size, which is 4. Yes, and okay, this thing, and m equals the mid value r minus l. L is right now 2 and L is right now 1 and R is equal to 3. which, and so 2, 1, and 1 plus 1 would be 2. So m equals 2 and II2 is 2 from here. II2 is 2 and 2 air 2 is 5, which is not right, which is larger than the target. It is not equal to target. Current value is lower than the target value. Therefore, okay, that is fucked up. Okay, current value is lower than the target. Current value C is lower than the target value. No, yeah, it is good. It is good. Here, our current value is greater than the target value. So R becomes equal to M at school, and M is right now, M was equal to 2, right? So L is still 1 and M is 2. L is 1 and M is 2. Let me start L at a lower value. Let's see. Now it does say 1, which is cool. Okay, invariance was not being kept. Yeah, because I was initializing L at I plus 1 and I plus 1 could be wrong. Yeah, I plus 1, yeah, might not hold the invariance. So that is wrong. See if it works. Okay, in the test case, it does work. False here. Answer should have been here when the answer is just the next one. Oh, not just the next one, it is equal, it is the last one. Let's use this test case 71411. Okay, I have something. I can do this. Shit. That is wrong. Wrong. Okay. 71411. 711411. And I would also like to print what I was printing after this. And yeah, II is totally working. Out it says 0, even though it shouldn't. I am seeing target, and while this see out if I am ever getting inside this thing, a new line. See, I am getting inside 14. So what is the problem? And I. Okay, I, and I am. Slang, not slash out. 0 and 2. So, okay, it is expected true. Why would you expect true? 7 is to the left of 14. The number on the left has to be twice the number on the right. So, why was this true? Well, I'm currently learning I'm currently learning DSA in Python and just created my LeetCode account. Today I am trying to solve easy problems, but I often find myself relying on GPT for help and end up just copying the syntax. I really want to improve my problem solving skills. What should I do? The thing that helped me in getting better at problem solving was this advent of code. And what is advent of code? Advent of code in this every year starting from 1st of December till 25th of December, you get two problems and you get two problems, part one and part two. You only get access to part two after you have solved part one, and the questions are in a way that is more digestible for people who are not programmers, who are beginners. And the way that the problems are represented, they are more digestible as a beginner. And so you just go there, read the problem, and whatever your solution is, you will get a dialog box right here. You enter the solution, you enter your answer for the problem, and the website will check if it is correct or wrong. And you also get like this is the input for this problem. So you write a program, you take the input from here, you read the input, you save the input in a file, then you read the input and run your program on this input and see if you are getting the right answer. So this helps you get started. This helps you to get started with thinking in programming terms, which is cool and also necessary. And yeah, cool. This is cool. You can start with this. But here, I think that why is it true? Is that the reason why a lot of people are unable to submit it? 43, 41% acceptance rate. Why is this thing true? Have I read this thing correctly? Given an array of integers, check if there exist these things. I is not equal to j and I is 0 equal to this and j is okay. Okay, their order does not matter, it seems. Okay, so if I ever find them equal, I don't have to check anything. Clang. Yeah, cool. So I can just make that change right here. Yep, it is correct now. And false. Okay, if okay. 0, 0, 0, 0. My output is false, and it should be true if both the elements are 0. Okay, I am checking for 0. Yeah, if this, even if it is 0, go and see if there are other zeros in the array. Okay, I could like write a very specific edge case in this or make it a bit more general. Yeah, I can do this. I can do this. Here, when it is same, I have to see that before returning this, if I not equal to I M, which just means that I not I not equal to M. If that is the case, we run this, else break for the current one, and I'll just copy this much, and it should work. Or it might not work. Why do I say false? Okay, I do not break. Break is wrong. I do not break. Okay. Because there might be a number later. Or okay, let me go to the washroom and I will be right back just in a minute. And okay, just use the test case and don't submit more. It decreases your accuracy and debugging skills. Okay, you are doing good. Thank you. Just don't submit more. Okay, 0 0 0 0, and I am only running the test case, so that is cool. Mm, so it is not working for 0 0. Let's see. Yeah, this change 0 0. Gland of the out and 1. It is outputting 1. Then why is it outputting false there? And yeah, voice is audible and stuff. Cool. So 0 0. Okay. 16 to 4. Copy. 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 Hmm, cool. Correct or maybe not. Okay, there are negatives. Shit. Does that change things? Negative numbers. I will have -20 to the left. Negative numbers. Negative. Let's see. minus 20, 12, minus 10, 12, minus 20, minus 8, 15, minus 10, 12, minus 20, minus 8, 15, and that window is extra. How do I delete a window? I guess, and yeah, kill window. That's out. It says 0. It shouldn't say 0. That is wrong. So, see out. Aye. Is clang plus 1 3 something, not OUTD out. And this, so it is saying that the smallest is at index 2, which is correct, and then the next smallest is at index 2, so it is sorted correctly. So till this point the answer is correct, but the problem comes later. Why would this even cause any problem? If the numbers are negative, it shouldn't cause any problem. While r minus l equals target C out C, if I ever reach this point. Nope, I do not, because I didn't save the thing. Yeah, I am getting used to this new key maps of mine. Why am I still printing the array? I am not printing because I am stupid. Clang plus 1 3 4 out, not slash out. Okay, okay, I'm never getting inside this thing. Why? Let's see. See out T, which is I am looking for this target. Okay, and then see out C space comma. Okay, and then see out a new line. And what slash out? I was looking for minus 40 and I never found it. Then I was looking for minus 20 and I never found it, strangely, even though I should have. Why is that a problem? Why was I unable to find it? Because minus 10 and minus 20 come side by side, and okay, now I go to minus 10 and I do not look to the left. Okay, that is a problem. Okay, that is a problem, because that is the only time when doubling a number actually increases the value. Doubling a number decreases the value, and it only happens for negative numbers. Okay, so I could, before sorting, go through the array and make all the take absolute values of all the numbers that would be cool, or that is one thing I could do, and it would also not change anything in the algorithm. It would not increase the time complexity a lot, because that would be done in 10 in n time, big O of n, and I'm already doing sorting, which takes n log n, so which is higher than big O of n, so that should not be a bad thing. But I do not want to do that. There should be something else. No, I guess that is the word. For auto reference x and a, x equals absolute of x. A is nothing. Of course, it is nothing. Just add this line here, and this should solve everything. Yep, it is. Or okay, shit. Of course, fuck, shit. Okay, for negative numbers, okay. I would have to look to the left for negative numbers. I can just change the boundary for those numbers. Right, yeah, instead of doing this. And why am I outputting? Okay, this. If t less than 0, if t is negative, that changes R and L. L becomes 0, or maybe no. L becomes -1, and R becomes I. Does it hold the invariance? R is always supposed to be greater than target. So no, R can become greater than I plus 1. And I also yeah, I have removed the absolute part. C. One, cool. Paste, and using this test case, let's see. Yo, hello brother, C++ or Java? C++. Okay, that is bad. That is bad. That is very bad. Why are why is everything else bad? Shit, I am always outputting false now. Okay, I guess this is the problem. Let's see. Now that should be correct, which it is, and submit. Okay. Okay, that's cool. Okay, how do normal people do this? For int ij. Shit. Oh, okay. This is what I wanted to avoid. This person is doing n square loop, which I didn't want to do. And can I go n square? I can go n square. N square is not bad, but still, this problem is a binary search problem. So I wanted to apply binary search, and my implementation is faster than this implementation. That is cool. And I mean, I am a beginner to programming. I have learned C. One day I want to become like Q. Or should I learn C++ or Java? Well, do not become like other people. Do not try to be like other people. And should I learn C++ or Java? I would say you should learn C++ because C++ is very hard and very complex. And by learning C++, I mean you should understand how things happen under the hood. That is, what is an object and how it is represented inside the memory. What is a class, how it is represented inside the memory, how compiler does stuff. But you are a beginner, so well, I am also a beginner. I'm like learning stuff. Everyone is a beginner. You can do CS50. CS50 is cool. If you are a total beginner, a noob, you can go to CS50. And this is amazing. This is a free course by Harvard. You can go and take that. Pretty cool thing. And it has been 2 hours and 46 minutes. That has been long enough. And that would be the end of today's stream. Yep, that would be the end of today's stream. And thank you for being here. Bye.